Dear aspirants, welcome to my channel. This is a model question paper 3. The branch is Electrical and Electronics Engineering, semester 2. Concepts of electrical circuit, subject code is 25 EE, 21 high. These are the 5 marks questions. So part D section 1, 5 marks questions. If you attend 5 questions, you will get 25 marks in the exam. So derive an expression for total capacitance when the capacitors are in series. So before going to that, capacitors are series. When the capacitors are connected in series, it is in same charge flows through the all capacitor and voltage, total voltage share among them. So this is the diagram. So capacitors are series, voltage is given. So A to B, B to C, C to D is a node. This is the voltage. A to B voltage 1, V2 and V3. They are represent letters C1, C2, C2 are capacitors in series. V1, V2, V3 as a voltage across say C1 and C2, C3. And V is a total applied voltage and Q will be the discharge of each capacitor. Coming to the derivation, here series are same, discharge flows through a capacitor, okay, Q. Charge each capacitor, let us consider Q. So voltage across the capacitor, we can write the formula V1 is equal to Q C1, V2 is equal to Q C2 and V3 is equal to Q C3. So total applied voltage is equal to V is equal to total voltage, overall voltage they represent V1, V2, V3, okay. So after that, substitute the values of V. We have calculated here V. We know the V value. Substitute in this equation each capacitor's V. So V1 Q C1 plus Q C2 Q C3. So take out Q is outside 1 by C1 plus 1 by C2 C3 1 by C3. Okay. So you will get this equation. After that, let us consider C is nothing but equivalent capacitance of the series combinations. So then V is equal to Q by CS. So you just compare nothing but you have to write the formula both. Let us consider this is 1, this is 2. So you have to compare, equate it. So Q divided by CS they are written. After that this equation they are written. So let us connect Q will be cancelled. Okay. So 1 by CS is equal to 1 by C1 plus C2 C3. So this is the formula, and if two capacitors, let us consider it is a 3 capacitor. If the key 2 capacitors will be there, what is the formula? Let us consider CS is equal to C1 plus C1 into C2 divided by C1 plus C2. This is derivation we have derived. Finally, the reciprocal of the total capacitance is series equal to sum of the reciprocal of the individual capacitance. Okay. The equivalent capacitance is always less than the smaller capacitors in a series condition. Okay. Next, explain the phenomena for mutual induction with help of the diagram. So before going to that, what do you mean by mutual induction? So mutual induction is a phenomena in which charging current in a coil induced EMF force in any nearby coil. Okay, this coil which carry the charging current, call it as a primary coil. The coil which EMF induced, that we call it as a secondary coil. Charging coil carrying the current, we call it as a primary coil. When the coil EMF is induced in the coil, that is we call it as a secondary. Coming to the how it will be working principle, what we have to do when switch AS is closed, current flows through a primary coil. The current produced in the magnetic field around the primary coil. When the current changes, the magnetic flux linked with the secondary coil also changes. Due to changing magnetic flux, EMF induced in the secondary coil, the induced EMF exists as long as current in the primary coil. And this mutual induction process induced EMF in one coil due to changing current in another near coil. This is basics principle used in transformers and many electrical devices. So this is the diagram for mutual induction. This is the diagram. There is a coil 1 and coil 2. Let us consider R1 and R2. So charges will be there. So first coil, the charges will be N1 and N2, and current will flow through induced EMF in the particular induction in the diagram. If they'll write, you can write the diagram. If you want more information, you can write this information. And this is the symbol of the mutual inductance, and mutual inductance means this is a formula. You can write the mutual inductance, and unit for that we can write it as an Henry. How the current which will be induced one coil to another coil, this is a formula. Okay, so applications you can use here for transformer, induction coil, and relays and chokes, and measuring the instrument, there you can remember. Okay, so what you may you just remember mutual induction occurs due to change in current. Next will be explain classification of secondary batteries with examples. So classification of secondary batteries. These secondary batteries rechargeable batteries in which electrical energy can be converted into chemical energy and reused many times. These batteries are classified based on a type of electrolyte and material used. One is an lead acid battery. So coming to the features of lead acid battery, it is used for lead peroxide and sponges lead plate, and it consisting of sulfuric acid used for electrolyte and rechargeable. You can rechargeable, and it is having a low cost. Coming to the an application. So you can use it for application, you can use it for automobiles, UPS systems, and emergency lightning. There you can use. Next will be a nickel cadmium battery. Coming to the features of nickel cadmium, we are using a nickel acid and cadmium electrolytes. It will give a long life and fast discharging. You can operate at a low temperature. Coming to the application, it is an portable tool, emergency equipments, and you can use it for radios. Next will be a nickel metal hydride battery. Coming to the feature, it is having high capacity than nickel cadmium battery. It is an environmental friendly. You can rechargeable many times. Coming to an application, we can use it for cameras, toys, and portable electronic devices. Next is lithium ion battery. Coming to the features, it is a lightweight and high energy density. It will give a long life and low maintenance and fast discharging capacity. Coming to an application which we can use it for microphones, laptops, and electrical vehicles. So secondary batteries are rechargeable, widely used for electronics and electrical application. Commonly we are using lead acid, nickel cadmium, and we can use it for lithium ion batteries. So next question, state and explain Kirchhoff voltage law. Coming to a statement for Kirchhoff voltage law, the algebraic sum of the voltage around any closed loop in any electrical circuit is zero. This means the total voltage supplied to a circuit which will be equal to the total voltage dropped in a loop. So coming to the explanation, so let us consider a closed loop circuit. Supplying voltage we call it as an V, and resistors let us consider R1 and R2. Current will represent high. Coming to according to Ohm's law, the voltage is dropped. So V1 is equal to high R1, V2 is equal to high R2. So apply Kirchhoff law loop. So V is equal to V minus V1, V2 is equal to 0. You can write V is equal to V1 plus V2. You can write it. The sum of the voltage rises will be equal to the sum of the voltage drop. So according to Kirchhoff voltage law state, the total voltage around any closed loop is zero. It is based on the law of conservation energy, and it is widely used for electrical circuit analysis. If the content is useful, please subscribe my channel and share and support. Remaining question I am going to upload next video. Thank you.